Okay. Hello, everybody. I will record this video about Xbar and R chart. So I will go over one example. We will learn how to calculate the control limits and central lines for Xbar and range chart, or it's called Xbar and R charts. So we use these charts to control the average and range. Okay, so the main goal of using these charts is to find out if our process is in control or no. Okay, so let's see this example. High voltage power supply, okay, uh, have a nominal output voltage of 350 volts, a sample of 4 units. So let's pay attention. So here a sample of 4. So our sample size is equal to 4. Okay? We will need that later. The data shown in table give the difference between the observed and the reading on each unit and the nominal set up. So when we say set up X bar, okay, and our charts on this process is the process in statistical control. That means we need to uh, plot the control charts for X bar and R. Okay, so we need to calculate the lower control limit for X bar, upper control limit for X bar, central line, and plot the process and see if the process is in control or not in control. So the first step we need to look at the data. So in this case, I have a sample size. The sample size is equal to 4 because I have 4 observations and I have 20 samples. Okay, so we need the sample size later to calculate the or to find the factors A2, D3, D4, and D2. Okay, so first I write the equations for the upper and lower control limits. So the upper control limit X bar is equal to X double bar plus A2 R bar. The lower control limit, I just subtract A2 R bar. The upper control limit R is equal to D4 times R bar. This is D3 times R bar. Let's go over each equation. The first equation, upper control limit X bar is equal to X double bar. X double bar means the average of averages. So I need to find X double bar based on the given data. Okay. And I need also to find R bar based on the given data. These factors, A2, D3, and D4, we'll find them later using the factor table. Let's first find X double bar. So I'm giving this data. I'm given this data, okay? So this data, I need to calculate X double bar and R bar for this data. You know, even I use my calculator or I use Excel to find the X double bar. Let's open an Excel sheet. Okay, here. I copy this. So X double bar, as we know, is equal, X double bar is equal the sum of X bar divided by the number of observations. Okay, the number of samples, let's say samples, it's easier. So I need to find X bar. So here in this example, X bar is not given, so I just need to find X bar for each sample, the average of these. So this is X bar for the sample one. I find the average for each sample for the 20 samples. Okay. And then I add them up. So I need to add them up, sum of these. So I have 206.5. So now this is equal to 206.5 divided by how many? 20. Okay, and I do the same thing for the range. Let's go back to our Excel sheet. So now we have 206.5 divided by 20. So we have X double bar here. We added up the averages, okay? And we divide by how many? In case if you are given, for example, sometimes you will not be given. So this is X bar, this is range. So the range here is, I find the range similar to maximum of these, okay, minus the minimum of these, okay. If I take these two columns, I copy them, I paste them here as values. So sometimes you are given just these two columns. That means, that's what you need. Just these two columns. Sometimes you will be given the summation, the total of this without the raw data. That means, you can use this data to find the uh, X double bar and uh, R bar. So now we have X double bar and we have this is sum of R divided by 20. So now we have X double bar and we have R bar. We already have this is 10.325 and this is 10.325. And so we need A2 from the table. I go to the table. Okay, this is our table, say based on the sample size. So in this case, our sample size is 4. I go 4, I need A2. So A2 is equal to 0.729. I need D3 is equal to 0 and D4 is equal to 0.282. I take these and I plug them in the equation and find what I need. I find, so this will be 0 because D3 is 0. I plug in here 2.282 times R bar, which is 6.25. This is will give me this. And then I have this 0.729 times plus I have 10.25 times 6.25. So this will be the upper control limit. I subtract this value. This will be the lower control limit. Then I take these and plot the control charts. I already have the data here. Look, I can do everything in Excel. I find X bar, which is the average of the first sample, scroll it down. This will give me the X bar, and then I can find the upper control limit, lower control limit, XD bar, and XL. For example, if I want to find the upper control limit, I just say the upper control limit is equal to XD bar, which is this H2 plus A2 for our case 0.729 times R bar is here. Okay, that's the upper control limit. I hit F4 here. Okay, and then I scroll it down and I get the uh, upper control limit, lower control limit, and I do the same thing for the other limits. And if I want to plot the X bar chart, I start with X bar, let's say. I go to insert, and then I click on this, select data, right click on the bar, select data, and I add the rest. What do I need to add? Upper control limit. I add the upper control limit for 21. Okay. And I also add the lower control limit X bar for 21. Okay. And I need the central line, which is XD bar. Okay, this is my chart. So now I look if there is anything out of up. This is the upper control limit. This is the lower control limit. This is the central line. These are X bars. Anything out of the control. So my process is in control here. I plot the R chart also and look at the R chart and see if there is anything out of the control. I don't see anything out of these lines. So I can say now that my process is in control. There is another example here, the hard break. It's the same. We are given this data. Okay. Here in this example, we are given already the X double bar, the R bar. If we are given only the summation, I can just divide the 37 divided by 25. This will give me the X double bar. And 8.3 divided by 20, this will give me the R bar. Okay. And I do the same thing. Look here, we have R bar is equal the sum of R from 1 to 25 divided by 25. So it is 0.321. And then I can calculate the lower control limit of R is equal to R bar times D3. D3 for this case is 0 because the sample size. Let's go back here. We have a sample size of 5. So I need to find here a sample size of 5. This is my A2. This is the D3. This is the D4. Okay. Okay. I find we said D4 is 2.14. We just found it from the table. Multiply it by R bar. R bar. We already have R bar here. And then this will be the upper control. The same thing, X double bar is equal to the sum of X bar divided by the number of samples, 25. We already have this here, it's 37 divided by how many samples we have, 25. Remember, there is a difference between the sample size and number of samples. This is n, small n. We use it to find the factors. This is we use to find X double bar and R bar. So we find X double bar, and then we plug in the X double bar here. We said we found this 0.577 and R bar already here. And then we find the uh, limits and we plot the data, our data here. See, nothing out of the control limits. This is the X bar chart. It's in control. And here probably we have one. It looks like out of the control limit. And here where we can calculate, we don't have farming. We just need to calculate the CP value. CP value. CP value is equal to upper specification limit minus lower specification limit divided by 6 times sigma hat. Okay, let's start with calculating sigma hat. Sigma hat is equal to R bar divided by D2. D2 is a constant from the table, a factor. It's a factor from the table based on the sample size. So we find we already have 3251 divided by 2.36. We already have this 2.36 from the table. See, this is D2, D small 2. See, this is our D2. We find it and divide. So we find our sigma hat is 0.3251 divided by 2326. So now we can find CP. Based on the given information, it says that the specification limit is 1.5 plus minus 0.5. So this is equal, so the upper specification limit is equal to 1.5 plus 0.5. The lower specification limit is equal to 1.5 minus 0.5. So this is equal to 2. This is equal to 1. Okay, so upper specification limit 2 minus 1 divided by 6 times sigma hat, which is already calculated here, 0.1398. Okay, so our CP is 1.192, a CP of 1.33. That means our process, you know, is not capable. CP hat means estimate should be above 1.33 to be capable. Okay, this is CPK. Okay, thank you.